Okay, week 2, homework 4.1 and chapter 4.2. One thing before I start solving problems, I want to let you know that under the video I will put the link to calculators I used during this recording. Also, I will place the link to the lecture for the topic so you can watch and understand. Okay, just follow the link and you will be fine. You can find the lecture and you will get to calculator I will use. Okay, determine the required value of the missing probability to make the distribution a discrete probability distribution. The thing is, the probability distribution is this p of x. And when x is equal 4, we have question mark. We need to find the value of probability for x is equal 4. How are we going to find it? We know the total probability maximum is 100% or 1. So if all probabilities are given but 1. So I'm taking the 1 and do minus 0.19, 0.55 and 0.8. Or add all these known probabilities, 0.19, 0.55, 0.08. Let me see. Let me clean this. This is stuck from the previous. Okay. So 0.19 plus, what do we have here? 0.55. And 0.08 plus 0.08. So how much we're gonna get here? 0.19 plus 0.55, that's gonna be 0.74, and 0.74 plus 0.08, it's gonna be 0.82. And then probability from x is equal 4, it's going to be equal 1 minus 0.82. So it's going to be 0.718. Okay, 0.18. And this is going to be the answer. 0.18. Fantastic. Moving to next question. So let's see, what do we have here? We have probability distribution. We need to find the mu. So to find the mu, let me see. Copy to clipboard. And let me see if I can paste it here. Okay, looks like we have to copy from here again, one more time. Oh, copy, okay, well, but how much it will copy? Only one piece? Let's see, if not, then I'll come up with other idea. Yeah, it's not copying, that's fine. I'll take a picture now. Okay, I'll take a picture and then place it to. Okay. And this is what we're going to have. X, here is probability of X. So we have 0, 0.043. We have 1, 0.058. We have 2, we have 0.159. We have 3, 0.264. We have 4, 0.221. We have 5, 0.168. We have 6, 0.087. So to find mu, the let me see, mu, the average of probability distribution, is equal sum of x times probability of x. So we need to multiply x by its probability and then add them up at the end. And well, you can do on okay, well, let me do it. Okay, x times probability of x. So this is going to be 0. This is going to be 0.058 times 2. Let me to go fast. I'm going just to use calculator. 0.159 times 2. It's going to be 0.318. Next, 3 times 0.264. It's going to be 0.792. Next, 4 times 0.221. It's equal 0.884. Next, 5 times 0.168. That is equal 0.84. And lastly, 6 times 0.087. And that is equal 0.522. Now we need to add them up. So I'm going to add it real quick. 0.522 plus 0.84 plus 0.884 plus 0.792 plus 0.318 plus 0.058, and that all is equal 3.414, and that is going to be our mu. Okay, 3.414. 3.414. How many decimals? 1 decimal, so it's going to be 3.4. Fantastic. Next, we need to find out variance. Okay, it's a little bit longer calculation, so I have prepared a calculator online. So let me go there. Inch calculator.com slash probability distribution, probability dash distribution dash calculator. Let's see if I typed it correct, if it brings up. Bingo, perfect. And I'll place this link at the bottom of the video in the comments, okay? All right, so let's work on it. So it's gonna be, I'm going to use the picture for x and probability of x. So we get here 0, here 0.043. Next, it's going to be 1. Here it's going to be 0.058. Okay. Next is going to be 2. Here we are getting 0.159. Here is going to be 3. And 0.264. Here is going to be 4. And this is going to be 0.221 and 5. And this is going to be 0.168 and 6. And here going to be 0.087. Okay, so calculate, and we will get everything we need. Mu we already calculated, standard deviation 1.5. Let me place the answer. 1.5. No, that was 1.5. The standard deviation. Variance I need 2.3 rounding. So it's going to be 2.3. Okay, good job. And then sigma standard deviation is going to be 1.5. Okay, I placed 1.4. Was it not 1.4? 1.5. That's funny. Okay, they leave space for some a little bit error, maybe, I don't know, but it should be 1.5. But it accepted, that means it accepts some range, a little bit error, leaving error plus minus 0.1 or something. Okay, let's do now interpretation. So interpret the result in the content of real-time situation. Result is going to be an employee works an average 3.4 overtime hours per week with standard deviation of approximately. There we go. That's a keyword. That's why it 1.4 it took it, but we're gonna put 1.5 because we know that it's gonna be it should be 1.5. Okay, because it's approximately suggesting calculation. That's why I took it 1.4. So I was right, telling that it's a leaving space for error. Checking the answer. Well done. Okay, next one, question number 3. So we're gonna solve here expected value. All right, I'm going to take a picture of these words that I can work this out, all this data given here. Okay, so now I'm moving to, we need to find expected value. I'm moving to here. So what do I have? I said I recommend you also take a picture or follow your work, the problem in your homework, so you can understand what's happening. So in the game, for now, let me open it so you can write down. In the game of roulette, a player can place $6 bet on the number 9 and number 9 and have probability 1.38. Okay, let me write down $6 bet for number 9 and probability 1/38. Probability of 9. Okay, next. If the metal ball, where is it? Here. If the metal ball lands on 9, the player gets to keep the $6 paid to play the game, and player is awarded an additional 210. Okay, so it's gonna be bonus $210. Okay. Otherwise, the player is awarded nothing, and in casino, and the casino takes player $6 if it lost. All right. This is win. This is loss, and it's gonna be minus $6, right? What is expected value what is the expected value of the game to the player? If you play the game 1,000 times, okay, how much would you expect to lose? Okay, we play this 1,000 times. Note that expected value is the amount on average. Okay, so what do we have? This is how we are going to solve this problem. We need to find expected value. All right? Okay. So first we need to find what's the probability, what's the value of winning. So if we are winning is 1 over 38. Let me write down how much it is. 1 divided by 38. It's 0.0263, for example. Okay, I round till that far. Okay. How much will be probability for losing $6? If for $6 is 0.0263, then probability for loss, which is going to be not 9, it's going to be 1 minus 0.0263, right? And 1 minus 0.0263, that will be 0. Let me move this here. That's going to be 0.9737. Okay, so now let's put equation together. So using formula x, sum of x times probability of x, we can write down. So we're going to write down that so when if you win, you're gonna get $210 times probability 0.0263, and if you lose, you are going to lose $6, so it's going to be minus 6 times probability of 0.9737. The word problem is solved like this, but I have disagreement a little bit with this, because when you win $210, in this $210 you still paid this $6. Realistically, it's going to be 210 minus this $6 that you paid, right? To win this $9. So it should be 210 minus 9, I would say, right? But they don't solve like that. So if you solve the right way, so this is a mistake here. If you solve this way, you won't get the correct answer. But I want you to know the correct way. You put $6 to be able to, you place $6 bet to win, right? Since we have 0.3192, so times 1,000, so negative 0.3192 times 1,000, it's going to be three zeros right here, multiplication. So I move the decimal position 1, 2, 3, and I'm getting 319.2. So 319.2 total loss, because it's playing 1,000 times, same game. 319.2. Now, why I don't put negative sign? Because it's already mentioning the loss, okay? And here it is. Well, let's take negative 0.32 rounded version, take and multiply by 1,000. It's going to be 320. Maybe they want to use the rounded version. 0.32 times 1,000. It's going to be 320. Well, correct, I was right. So, okay, you take this 0.32 rounded version of it. Okay, moving to next question. So, uh, find the mean, variance, and standard deviation of the binomial distribution with the given value of n and p. This is what I'm going to do. I'm going to tell you how to calculate the formula, and then so you would be familiar, and then bring to online calculator for binomial distribution, so make it easy your calculation. So first of all, for binomial distribution, mu, it's a mean, is equal n times p. The total amount of trials and times probability of success. Next, the standard deviation or variance, let's start with variance, sigma squared is equal npq. Q is a probability of failure, which means Q is equal 1 minus P. Okay? Let me put different color here. All right. And sigma standard deviation, accordingly, it's going to be NPQ. Okay. Okay, let's solve it. What we have here, N is 70, P is 0.8. N is 70, oops. P is 0.8, which means Q is going to be 0.2. Okay, we need to find average, right? Mu, okay. Mu is going to be equal 70 times 0.8. That's going to be 56. Let's put it here. Oops. Good job. Next one, we need to find which one? Variance, NPQ. So since we know NP is 56, so sigma squared, it's going to be 56 times 0.2. So 56 times 2 is 12, 10, 12, 11.2. Okay. And lastly, standard deviation, sigma. Sigma is going to be square root of 12.2. Let me take square root 12.2. Where is square root here? 3 point, how many decimals? 1, 3.5. Okay, let's put in there nearest 10, 3.5. Okay. I don't understand. 3.49. So 11.2. I'm sorry. 11.2 and I put 12.2, so 11.2, 3 well, there are big numbers, too many big numbers. I don't know if it's 3.3 or 3.4. It's gonna require, let's put 3.3. If not, then we have last attempt and that would be correct. It's all about rounding because I have 3.3466. So if I round it, I will get 3.35, which will be 3.4. But I don't know if they ignore that 6 is there. Well, let's see. Well, yeah, they did ignore 3.3. Okay, that's fine. For question number 5. So let's move to next question, question number 5. A state lottery randomly chooses 4 balls numbered from 1 through 38 without replacement. Okay, they don't replace it. You choose 4 numbers and purchase a lottery ticket. The random variable represents the number of matches on your ticket to the numbers drawn in the lottery. Determine whether the experiment is binomial. If so, identify success. Specify the values NP and Q and list possible values of the random variable. Okay, let's list all properties of binomial distribution. So let's do it. Binomial distribution. So first one, all trials are independent. And the fact that they do it without replacement, they don't put back. Let's say if you had 8 elements, you took 1 out, there left 7, and they don't put it back, that already make dependable, so which is not binomial. But let's finish all properties. We have to have specific amount of success. What do I need by that? Amount of success. Let's say I went to the beach to see, let's say, dolphins. If I say I saw more or less than 5, for example, dolphin, that's not specific amount. It has to be, I saw the 4 dolphins, that's specific amount. And then we need to have this all trial. First of all, this is value of n, this is value of x, and then the probability of success. Okay, that's our p value, that's percentage, and q going to be 1 more minus p. So let's read it. See it here, it says numbered 1 through 38 without replacement. If you don't replace, that's already not independent, it's dependent. Therefore, we're going to say that no, because the probability of success is different for each trial. Okay, so if total we have 38 and I chose 4 balls, it's going to be 4 out of 38. And if you don't replace it, so instead of 38, I will have 37 left. So probability of second one I take out, it's going to be 4 out of 37. We understand? So it's not the same. Okay, let's check it. Next one, identify identify success. Well, there is nothing to identify the success because experiment is not binomial. We already figured out in first case. Okay, next it's asking for values. We can't put any values because experiment is not binomial. Okay, what else we have? List the probabilities. So we can't list anything because experiment is not binomial. Okay, moving to question number 6. So 45% of households say they would feel secure if they had 50,000 in savings. You randomly select 8 households and ask them if they would feel secure if they had 50,000 in savings. Find the probability that the number that say they would feel secure is exactly 5. Okay. So here we are going to use binomial calculator. So let's write down x is, we need to find, they say would feel secure exactly 5. This is going to be our x. X is equal 5. What else we have? Total 45, they feel that 50,000 in saving. Okay. It was n is equal 60,000. number, that the number they say they would. Okay, 50,000, n is equal 50,000. What is the probability of success? Oh, this is total, n is 8. Okay, hold on. You randomly select 8 households. Okay. This is 8 households. I didn't see there at 8. Okay, n is 8, x is 5. We need to find probability, and that's what we need to do. 45% here at the very beginning, 45%, p is 45%. 0.45. Okay, now let's go to online net. Okay, so number of trials was 8. Probability 0.45. And number of success was 5. Okay. Calculate. There we go. So we need probability of distribution of x. And there we go, probability of exactly x is equal to 5, 0.1719. Let's see how many decimals they want. Three decimals. 0.17. How much was it? 172. Rounding. Fantastic. Next we need to find the probability that the number that say they would feel secure is more than 5. All right, so here we have more than 5. We totally had 8, so it's going to be 6, 7, 8. So probability of 6, which is going to be, I'm going to write down on a piece of paper. And I'm going to round till 3 digits because they require 3 digits only. So after 5, it's going to be 6, 0.07, well, it's 0. Probability of 7, 0.016, and probability of 8, 0.002. Okay, so it's going to be 2, 8, 0, 0, 0.088. Let's move back and type it in. 0.088. Excellent. Okay, next we need to find less or equal 5, which means we are going to go back. So I would suggest, so either add from 0 all the way to 5, or the easier way would be, since we know 6, 7, 8, so in total is 100%. So if I take 1 and subtract the 6, 7, 8, I will get from 0 to 5, right? So what I'm going to do, I'm going to take 1 and minus the previous answer, 0.088, subtracting the sum of more than 5, and I will get less equal 5. 0.912. Very good. Okay, I think we're done with this. Moving to next question, and that's question number 7. Assume when adults with smartphones are randomly selected, 46%, that's going to be our P, the probability of success. P is 48, right? I think, yeah, 46, okay. I'm going to clean this. 46%, okay. Use them in the meetings of class. If 6 adult smartphone users are randomly selected, which is our N, Find the probability exactly free. Our x is gonna be free. Probability for free. 36046. Okay. Let's work on it. So I have to return back. Okay. Trial 6. How much was that? X is free. Okay. So this is 6,046. And free, number of success free. Okay. Click calculate. Exactly, it's going to be 0.307. Okay, 0.307. Zero point 307. How is it wrong? Round decimal to 4 decimals. Okay, 4 decimals. 3065. Okay. Okay, very good. Next one. Okay, moving to next problem. N is 128, P045. N is 128. X we don't know yet, so we shall see. Oh, okay, we need to find mean. So mean is going to be 128 times 0.45. 128 times 0.45, and we are getting 57.6. 57.6. Okay. Variance is going to be Npq, since Np is 57.6. Coming back here. Np, it's going to be mu is equal 57.6. And that is Np, N times P. Sigma is equal Npq, sigma squared. So if Np is 57.6 and Q is equal, how much is our Q? Let's see, our percentage was how much? 0.45 percentage. So that means it's going to be, Q is going to be 55, 0.55, right? 1 minus 0.45. And this is going to be equal 57.6 times 0.55 and 4.18. Okay. It says till nearest 10th, which is going to be 4.2 instead of 18th. What is wrong? .6 times 0.55, because our probability is 0.45. Yeah, so it's going to be 0.55, and the result is 3168. How did I get the wrong one? 3168, so if I round it, it's going to be 31.2. I guess I had some numbers left in memory, didn't clean well. 31.7, okay. And standard deviation, it's going to be square root of 31.68. 5.7, how many? Okay, 1 decimal. Five point seven. Again? Oh, 5.6. You think only you have enough? Come to me. 5.6. Okay. Well done. Question number 9. Well, we already solved something like this many times. So mu is going to be 0.79, right? Let me see. 0.79. 6 workers, they choose 6 workers times 6. 0.79 times 6. Because you randomly select 6 workers. It's going to be, until nearest 10, 3.7. Let me clean memory again. So 6, indeed, how can be 3.7? It's 80 or 79%, going to be much more. Okay, let's do one more time. 6 times 0.79. 4.74. This is my calculator and it's on iPhone. 4.7. Okay. And now 4.7, I have to multiply by Q, and Q is going to be the rest from 79%. So 100% minus 79 is going to be 21%, meaning times 0.21. 0. Okay, one more time. 4.7, I don't trust my calculator anymore. 4.7 times, that's N times P, now times Q. Q is going to be 21, 0.21. And 0.987, so nearest 10th, 9.9. So it's going to be 0.99. Okay, I'm using on different calculator now. Let me check it because there is no magic. 4.7 times 0.21. 0.987. If I round it, 0.99. Okay, well, let's check it. Let's see what they suggest. We got it. One more time, final. Let me see what they answer. Oh my God. They said the nearest 10th. How much I had? 0.99? Oh, rounding. Okay, at least you know. Yeah, if I round one more, it's gonna be 1.0. Okay, well. Now, standard deviation, I'm going to take square root of 1. It's gonna be 1. Okay. Moving to question number 10. Oh, we have one more here. Interpret the result. So on average, how much is our average? 4.7. And then here, it's gonna be standard deviation of 1. The numbers of workers who know looks would be different average number for no more than 1.0. Okay. I'll just place the numbers I had already solved. Okay, 32%, it's also a binomial distribution, which is 0.32. Okay, total 12 adults, and how many, not, it's exactly free. Okay, X is free, N is 12, and probability of success 0.32. Let's see. Twelve, 32, and here we get free. And how many decimals? We need to be careful. Thousands. Okay, 3 digits. It's gonna be 0.224. Okay. More than 4, since we already have it, more than 4, it's gonna be how much? Oh, here it is, more than 4. It's easier, instead of going more than 4, because there are 9, 10, 12. So only more, right? More equal. So I'm going to take from 0 to 3, okay, and do 1 minus, let me write down. So probability for x greater equal 4, I'm going to take 1 minus, and probability for x is less than 4, which is going to be probability of x is equal 1, all the way add probability of 2, probability of 3. That's what it's going to be, right? And that would be less than 4. So, okay, let's do it. 1 is how much? 0.009. We're going to keep 3 digits. 0.0. If I do round till third digits, it's going to be 0.010. Okay. Next, 0.055. And second one is 0.143. Oh, here I forgot to put 0 also. Okay. 0.143, that's the probability of 2, and probability of 3 is gonna be 0.224. 0.224. Okay, so I'm going to do 1 minus, so probability of 0, it's going to be 0.010, and then minus 0.055 minus 0.143 minus probability of 3, 0.224, and that's it, and we are getting 0.568. 0.568. Correct. Now lesson 2, so it's going to be 0, 1, and 2. So let me add them up. 0, it's going to be 0.010, plus 1 is going to be 0.055, plus, and 2 will be 0.14 and 3. That is 2, and we need it less equal. Oh, less equal 2. So we have it, 0.143. 0.143. So we added 0, 1, and 2. Did I add by chance 3 also? Let me see. Okay, let me subtract the third one, 0.224. No, okay. Messed up my calculator. So 0, 1, and 2. So 0.010 plus 0.055 plus 0.143. Okay, 0.208.